Acid strength and molecular structure. So we kind of had these questions pop up. Why do some hydrogen-containing molecules act as acids and others don't? Why is H2S an acid, but CH4 isn't? CH4 has hydrogens in it. Why isn't it an acid? Why are some acids strong and some are weak? Why is HCl strong, but HF is a weak acid? It has to do with the molecular structure. So first we're going to look at just the binary acids, not the oxyacids. So here if we have hydrogen and some generic element Y, okay, in order for this molecule to act as an acid, it must be able to donate this hydrogen as a hydrogen ion, right? And what affects its ability to do that is the polarity of this bond and the strength of the bond. So if we look at this again, if we have a bond polarity where Y is more electronegative than the hydrogen, we've got a dipole going on here. We have a partial positive charge on the hydrogen, partial negative charge on the other element. This is promising for acidic behavior because we've got the hydrogen ion at the positive pole of this polar bond, and so losing this as a hydrogen ion is going to be a pretty easy thing to do. We have to have the hydrogen lost as hydrogen plus, and so that partial positive charge makes that easier. So if we look at these three substances here, HLI, like, well, that's a weird, yeah, that is kind of a weird compound. But here, the hydrogen is the negative pole, and the lithium is the positive pole, right? And so this is not going to be acidic. This is not going to lose an H plus ion. It could possibly lose a hydride ion, an H minus, but that's not an acid. So this is no acidic behavior. The carbon-hydrogen bond is not polar. The electronegativity difference there is only 0.4, and so that's considered a nonpolar bond. We don't have a dipole moment at all. Carbon-hydrogen bonds are not acidic. Here with hydrogen and fluorine, the fluorine's more electronegative, and so hydrogen is at the positive end of this, and this is acidic. Does that make sense? Bond strength also affects it. So the stronger the bond with that hydrogen is, the weaker the acid is. So if the bond is very weak, then the acid's going to be strong, right? And again, we've got this opposite business going on. And so, yeah, flat out memorizing that I don't think is a great idea. Just kind of think it through. So if that hydrogen is held very tightly, if the bond is strong, is that going to ionize easily? No. It's only going to ionize a little bit because we've got to pull that hydrogen ion off. If the bond is very weak, then it will very easily lose the hydrogen ion and it'll be a stronger acid. Does that make sense? So if we look at these acids here, HF, HCl, HBr, the bond energy is highest in the HF bond, and that is a weak acid. Because the bond is strong, the fluorine doesn't want to let go of the hydrogen ion. HCl and HBr are considered strong acids. The bond energy, the strength of the bond there is weaker, so they are stronger acids. Because I don't know if it bothers you, it bothers me that in this halogen family here, HCl, HBr, HI, those are strong acids. Why not HF? Because the bond there is too strong. And so it's not going to ionize completely. So we see a trend. There's a combined effect here. As we get increasing electronegativity, then we get increasing acidity. Because then you've got more, the bond is more polar. The hydrogen is already more positive than in a less electronegative element. And then we have decreasing strength of the bond as you go down, causing increasing acidity. So why is this bond with HI weaker than HF? This is back to Chem 1A. Yeah?
Because HI is larger, so it's holding the hydrogens farther away.
Yes, because iodine is a much larger atom than fluorine is. And so the hydrogen cannot get as close to the iodine nucleus. Right? And so as atoms or ions get larger and larger, the attractive forces between them become weaker. So as we go down, these get to be stronger acids because it's harder for them to stick together. Any questions? So what about the oxyacids? The oxyacids, we've got oxygen, of course, and hydrogen. So we've got oxygen. The hydrogen is attached to the oxygen is attached to some other element. Could be chlorine, nitrogen, sulfur, something like that. This element may or may not be attached to other oxygens. Just depends. So the electronegativity of that element Y is going to have an effect on the strength of the acid. If element Y here is more electronegative, it's going to pull electron density away from the oxygen and the hydrogen, and it's going to weaken that bond. If this bond is weak, it's a stronger acid. So we look here, this would be hypoiodic acid, hypobromous acid, and hypochlorous acid. Okay, electronegativity, the chlorine is more electronegative. So it's pulling electron density away from the oxygen and hydrogen. And so this hydrogen has a larger partial positive charge and the bond is weaker. And so we see that the Ka value for this hypochlorous acid is larger than for the HOBr. And the HOI is even smaller. That make any sense? You gotta think about, well, what's making that hydrogen-oxygen bond weaker? Whatever makes it weaker makes the acid stronger. The number of oxygen atoms. So the more oxygen atoms you have bonded to that central atom, the Y atom, the stronger the acid is. Because those extra oxygen atoms, being highly electronegative, are going to pull electron density away. So here we've got hypochloric acid. So here we've got the chlorine in the middle. The hydrogen in an oxyacid is always on one of the oxygens. So these oxygens bonded to this chlorine are going to be pulling electron density away from the oxygen-hydrogen bond. Makes that weaker, makes the acid stronger. So there we've got 4 oxygens. Here we've just got 3 oxygens. So we've got 2 additional oxygens besides that one pulling electron density away. It doesn't pull as strongly. And so this bond is a little stronger. This is not a weak acid. I'm sorry, it's not a strong acid. It's a weak acid. Its Ka is 1. It's pretty high for a weak acid, but still. And as we go fewer oxygens, the Ka value gets smaller. So that's why perchloric acid is a strong acid. Chloric acid is not. Nitric acid is strong, but nitrous acid with the 2 oxygens is weak. Sulfuric acid is strong. Sulfurous acid is weak. Number of oxygens. Any questions?